Hello friends, how are you? Hope till now you have completed the theoretical and conceptual aspects of this very important topic, that is wave optics of class 12th. So what we decided on the basis of our observation, we found that lot of questions from this topic they used to be asked in your this NEET entrance exam. So we decided to prepare few videos in which we will provide you a collection of good questions so that you can revise, you can get the better understanding of your concepts in this particular topic of wave optics. Fine. So with this motive we are starting these videos one by one. It's not like that this is the only video. In this sequence we will keep on providing you at different point of time different videos. Fine. The only suggestion to all of you is, don't consider these problems as just for the sake of solving these problems. Try to understand in totality the concepts, because if you are in a position to grasp the question properly, at any point of time you can solve any problem. Fine. But if you are just solving the problem, okay, I'll have to only solve it, that way it's not going to fulfill any of the purpose. Fine. So just be the part of this discussion. I will first explain the problem and then one by one I'll keep on moving on to the solution and discussion of the topics. Okay. Whenever it is required, wherever it is required, I will definitely provide you the, you can say, some sort of re-explanation or revision type of thing also that is associated with that particular question. Fine. So here we are starting this discussion with a very simple but a conceptual question. And what is that question? Interference is possible in what type of waves? Fine. So that is the first question, which is just trying to check how much you have the understanding of the phenomena of interference, or related topic is diffraction, or other related topic is polarization, something like that. Fine. So over here we are going to focus only onto the interference. Now interference, diffraction, reflection, these are the concepts associated with any type of waves, whether they are mechanical waves, longitudinal mechanical waves, or you can say your these type of waves. Fine. So interference is something which is not only possible in electromagnetic or transverse wave, not only possible in longitudinal mechanical waves, sound waves, but interference, diffraction and you can say reflection, all these type of concepts, they are applicable for any type of waves. So the correct option is C, both light and sound waves. But I want to move a step further. What? That I want to mention a simple statement for your better understanding. What is that simple statement? That is, let me allow to write down, interference, it is for your understanding. Interference, fine. Second concept is diffraction. Diffraction. Next you can say reflection. Fine. These type of phenomena applicable, I mean, why I am using this dot dot, because other concepts like transmission and so on. So interference, diffraction, reflection, all these concepts are applicable for all waves, all types of waves, all types of waves. Okay. So this is something which is applicable to all types of waves. Now, this is the approach that you can say a proper approach. Reason being, rather than only learning interference, we also revised our concept of this phenomena, that these concepts are applicable of all types of wave. Now, what exactly I want to prove by this way? See, for example, if you are picking questions, let's say from chapter X. Fine. So if you decided, okay, I will solve n number of problems from chapter X, Y, Z, something like that. So not only that question, but read the question, think all associated concepts, only then provide the solution. So this is the best approach of revising in totality of that particular topic. Fine. Because you don't know in competitive exams what exactly they are going to ask. So in this manner, if you are preparing for your exams, obviously it is going to pay you lot. Fine. Next is this question. Now this question is basically from a very important topic. Why? Because if you are talking about YDSE, that is Young's double slit experiment, basically it's the name of a scientist, as I explained during the discussion of theoretical topics of this chapter. At that point of time, I explained you that by the experimental setup of Young's, it has been proved that phenomena of interference is taking place. So it was like you were trying to prove, yes, these are waves. Fine. So this topic, this name, this concept is so important that every time IIT JEE Advanced, IIT JEE Mains, NEET entrance exam or any other entrance exam, you are, supposed you are bound to get questions from this category. Fine. So never ever ignore this topic. Okay. Here I am just picking a very simple question. Fine. What exactly the problem? In Young's double slit experiment YDSE, the separation between the slits is halved and the distance between the slits and screens is double. The fringe width is how much changed? What will happen if we will do that? Okay, so just before jumping for the solution, let me quickly give you just for a few seconds the basic idea of this Young's double slit experiment. Then I think it's going to be easier for you to understand. Now listen carefully. Try to recall at that point of time of explanation what I used. I said there is one this source S. It's a light source. In front of this source, place a screen. Okay. After that, at equal distance, create two small slits, two small openings, and the size of the opening is going to be in the form of micrometer. Fine. Millimeter, micrometer type of thing, very small. Let's say this is S1, this is S2. So what will happen? Light waves. Now, sorry, this is not allowed. This is not allowed. What will happen? As per Huygens principle, this S1 and S2 will start acting as two independent sources. So from this, what will happen? This way. Similarly, from here. Now, consider this cutting, consider this, and so on. And then you are placing a screen. Fine. So this distance is defined as capital D. That is distance between S1, S2 and screen. This is screen. And here this gapping is defined as spacing between two slits. Wavelength of the light used. Fine. So at that point of time, I explained a formula to you, that is d lambda over small d. What is small d? Small d is your this much distance. This is small d. and this is capital D, and lambda is the wavelength of the light used. Fine. Now, once the diagram is clear, the formula is clear, what is left? Next left is try to read the problem and then try to find out the solution. Okay, now let's read it. The separation between the slits is half. Okay, so we have to write down the formula twice. This is first condition. Second condition is beta prime, beta or W, fine, prime. Why prime? Because now it is bound to change. Beta prime is equal to, it is D, so next time it is D by 2, or you can simply say 1 by 2. Okay, 1 by 2. Then distance between the slits and screen is double. So earlier it was D, now it is 2D. Okay, so let's say it is 2. Fine. I am not putting this lambda and this DD because I have explained this. So ultimately you can say beta prime is equal to 2 into 2 by 1, that is 4. So what exactly you can find out from this? You can find out that the correct answer is quadrupole, that is 4 times of the initial value, fringe width, going to change by 4 times. Why? Because this spacing has been reduced half, this gapping has been increased double. So the solution is in front of you. Okay. As such, if you are trying to attempt these problems in this fashion, so what will happen? At any point of time, you will never ever going to be confused. Fine. This is the approach for competitive exams. And in examination hall, you can't do any experiment. Whatever experiment you want to perform, you have to perform during your studies. So that in examination hall, you should be very comfortable. 45 questions and just less than 45 minutes time. So try your best to minimize the utilization of time so that you can save some amount of time for your tough questions, for your long questions. Okay, this is the best approach. Now, here is one question. In general, if you read the question paper of NEET previous year exams, AIMS previous year exams, you will find around 3-4 questions. They love to ask that, that is just mean to check, is it possible for you to remember some important formulae or not? Fine. Because here no concept is applied, here no calculation is required. Either you know this result, I mean this formula, or you don't know. So it's like that you are going to talk in terms of digital parameters like 0 or 1, yes or no, low or high. So my simple point is, please at least few important results during your studies you should try to practice them by writing, because it's not like that, it's not possible for you to remember like that V is equal to I max minus I min upon I max plus I min, nothing like that. You have to write down the complete formula once, twice, thrice, and after writing it for 7, 8, 10 times, after that you are going to be comfortable. So here the correct result is A because it is a formula, but I would like to mention one simple line over here. And what is that line? That is fringe visibility, fringe visibility V is given by this formula. Now what you should do, actually this is something what I did during my preparation for IIT's entrance exam. Take a A4 size paper and at least use 3 or 4 color pen or pencil. Write down some small sentence and then the formula. Again with different color, small sentence, formula. And then by this method, when the entire A4 sheet is completed, paste it in front of your eyes wherever you are studying in your study room, and it will ensure that at least in a single day 4, 5, 6 times you can take a look of these important formulae like this. Okay, fringe visibility is given by this, fringe width is this much, and so on so forth. So it's going to be a regular thing for your eyes. So it's going to be stored in your hard disk. So that is the way of recalling, remembering some important results, and this Young's double slit formula or concepts and these type of small results, they are really very important for this particular situation. Now let's move ahead for the next problem. Fine. And from this problem onwards, means the fourth problem onwards, I will try to introduce a small amount of calculations. Fine, because the videos that we are posting on our site, I mean misostudy.com, from medical stream students, we are getting requests like that we are not very much comfortable in mathematics. So at least whenever you are providing a question with calculation or something, please provide in totality. So what I will do, definitely I will try my best to provide the in-depth solution. Okay. Now this is the question. The very first thing is, moment you people, I mean it's as a habit, moment you watch these type of questions, your approach is very difficult question, let's move ahead. Don't do like that. At least if simple questions, 2-3 questions you are able to solve in 1 or 2 minutes, then at least you should try to devote some amount of time for these questions. Reason being, sometimes the language, the design of the question is like that, it creates repulsion, while the question itself is a very simple one. But it just creates a fear in your mind, oh my god, this is a very difficult question, let's move ahead. And by that, I mean, it's a escapist tendency, and after the exam when you read these questions, you may say, oh my god, these were so simple questions and we failed to attempt. So don't do that thing. At least first hand reading must be from your side. Let's try to understand. Two sources of lights of wavelength 2500 angstrom and 3500 angstrom are used in Young's double slit experiment. You can say two setups have been created. Okay. And because it is mentioned simultaneously, so two setups created means once you perform the experiment using this wavelength and next time using this wavelength. Which orders of fringes of two wavelength patterns coincide? Now, what exactly this question? I am unable to understand. I mean, this is very difficult to visualize. That's why in second question I created that simple diagram. Okay. So let's first try to translate the problem. What exactly the problem is? Okay. Let's try to understand. Same setup like S, then S1, S2. Okay. From here, fine, this way. Now, beta is equal to lambda d upon d. Just 2 minutes back we discussed it. It means if we change lambda keeping other these two parameters fixed, obviously beta will change, fringe width will change. So fringe width if going to be changed, then on the screen the pattern is also going to vary. Fine, because we are using two wavelengths. So idea is, once perform the experiment, mark the points, then again use another this wavelength and perform the experiment. Then you have to find out which one is the case of overlapping. Fine. So now few lines I am going to write down. I hope the question is now clear to all of you. Right now, don't try to listen these people. For us right now they are not meaningful, because first I will try to solve the problem, then I will analyze these solutions. Fine, these options. Let nth bright fringe, let nth bright fringe, fine, because it is mentioned, used in Young's double slit experiment, which order of fringes of two wavelengths pattern coincide. So let nth bright fringe of 2500 angstrom is coinciding, I think it's not correct, coinciding. Fine. Let nth bright fringe of lambda 1 or 2500 angstrom is coinciding with n minus 2th fringe of 3500 angstrom. Now, few of you may think why the teacher is writing this line. Point is simple. I may solve this problem in just 2 steps, but here I am not learning the problem. Here my point is to explain you the approach how you can learn. That's why I am doing this much. Fine. So, let's assume that for lambda 1 nth bright fringe coincides with n minus 2th bright fringe. Okay. Now, lot of you will start thinking, what's the point of this term? How the teacher is saying nth bright fringe with n minus 2th bright this fringe? How exactly? Is there any formula over here? Nothing. So how it happens? So all those students who are regularly watching our videos, for them it's a simple thing. But if you are first time watching this video, obviously you will find it difficult. So right now I am not going to explain this point because this is very properly explained in our regular videos or theoretical videos. I would like to suggest and request all of you, first watch our theory videos, concept videos, and then go for these problems. Fine? Because here if I will start explaining the concepts, each and every concept, then the very purpose of these problem discussion video shoots is going to be failed. Fine. But yes, this yellow color point which I marked over here, definitely you have to take care of this aspect. Please. Now, let's put a simple value over here. And what is that value? That is 350, that is this lambda to n minus 2, fine, is equal to this value 2500n. Ultimately we have to find the value of n. Fine. So let's understand it. It's 3500n minus 7000 is equal to 2500n. Now transfer and arrange the terms. So 3500n minus 2500n is equal to 7000. Fine. So 1000 n is equal to 700. Now just cancel. So n is equal to 7. So now what exactly your answer? Now after this please start reading the options. Third order of first source and fifth of the second? No. Next, seventh order of first and fifth order of second. Very much clear. Why? Why? Now, put the value n 7. Put the value n 7 minus 2. So 5 and 7. So exactly 7th order of first and 5th order of the second. Come back again. 5th order of first and 3rd order? No. 5th order of first and 7th order of second? No. It is not. It is reverse of that as per the language of the question. So correct answer is going to be your B. Fine. You can say the approach of these questions is not difficult. Fine. But yes, in NEET entrance exam, see the basic difference between IIT and NEET medical entrance exam is, in IITs they provide questions with lot of calculations and correlated other concepts. But for NEET entrance exam, questions are simple, straightforward, but they checks your basic understanding very much. So be careful at this aspect. Okay. Now let's move ahead for the next problem. Angular width of central maxima of a diffraction pattern. Till now concept was associated with interference. Now gradually I am switching for the next phenomena, that is diffraction. Diffraction pattern of single slit, okay, not depend upon. Over here again the same approach, which now I am not going to elaborate because in last 3-4 questions I explained the approach. First stop my video here itself, fine, then at least give 2 minutes time for revision of important concepts of diffraction, some formulae, some direct results, some concepts and the diagram. After that run the video and then whatever I am going to explain, please try to understand. Okay, this question is up to some extent directly based upon a simple formula. So after solving only we will start reading these options. Before that there is no point of reading the options, fine. Angular width of central maxima. Angular width of central maxima, fine. Now how it is given? It is given as theta is equal to beta upon capital D, where symbols have their usual meaning, fine. Now these two results are very important. Basically in this entire chapter of wave optics, important aspect is interference and diffraction, and of course some portions devoted to polarization also, fine. So this result is something which is important for your understanding. Then please try to solve it. Theta is equal to beta upon D, and what is the value of beta? Just 5 minutes back we discussed beta itself is equal to 2 lambda capital D upon small d. Okay, so let's try to put the value of this, that is 2 lambda D upon AD, D small d capital D, anything like that, because it is the diffraction phenomena. So rather than using slit spacing small d, because it is mentioned it's a single slit, so we use the idea that the slit width of the single slit is small a. Obviously d and d cancel, so theta is equal to 2 lambda upon a. Now what is very much clear from this particular aspect? It is clear that fringe width theta is totally independent of this capital D. And what is the capital D? Capital D is the spacing between screen and this fringe, fine. So this angular width has nothing to do with the capital D term, fine. So now if you try to find out the answer, then you may say wavelength of the light used, yes, it depends. Width of the slit depends. Frequency of the light used, actually directly over here frequency is not showing you, but don't you think you should try to correlate lambda with the frequency using speed of light c? So ultimately this is also not correct. Ultimately correct is distance between slit and source, capital D. Capital D is distance between slit and source. So why I am explaining this? Because if you started learning like this, then in examination hall by default you are going to attempt questions correctly, because now it's your habit. So what will happen? Moment you will start reading the question, your brain will start analyzing and your hand will ultimately pick the correct choice. So here we would like to move ahead for the next set of questions, and if you revise these problems, very good. If you don't revise these problems, good, not very good. Why I am saying so? If you revise these problems, you will learn the concepts. If you will not revise, somewhere somehow you will lack, Fine. So at least you should try to devote good amount of time for revision also. Here is your next question. Ray of light is incident on the surface of a glass plate at an angle of incidence equal to Brewster angle. So now I hope this term itself will give you the clarity that this question is nothing but simply from the phenomena of polarization. Polarization. Nothing else, nothing more. Fine. If mu represents refractive index of glass with respect to air, then the angle between the reflected and the refracted ray is simple, 90 degree, using Malus law, MALU''S. That law is, only two laws are given, Brewster which is mentioned over here. So basically in this question there is no scope left for any type of guess. No need to apply anything. Question is from polarization and answer is going to be 90 degree. So if these two laws, Malus law and Brewster law, you are aware, yes, 4 marks without any effort. Okay. After this, actually again see the same approach. Question quite long, options very complicated, and if your tendency is having with this nature like escapist, without reading the problem jump away, what will happen? This so simple question, just because of some sort of this makeup, you are going to lose 4 marks. So please don't do this at least. Fine. Now what is the next problem? So next problem is this one. If ratio of amplitude of two waves is 4/3, amplitude ratio A1 upon A2, then ratio of maximum and minimum intensity. Now before saying anything, if simply I am saying I max upon I min is equal to A plus B, A1 plus A2 or AB, something like that, square upon A minus B whole square, I am sure you all are going to be very comfortable with this explanation. This is a basic result, basically this is a basic result. Now what is the value of A? A value is 4. What is the value of this B? That is 3. So you can solve by putting the values, or best approach of solving is write it like this way. Fine. What is that way? B square A by B plus 1 whole square. I am using, that's why this yellow color chalk. Again B square A by B minus 1 whole square. Fine. Simply put the values of AB ratio, you will get I max upon I min 49/1. Fine. So question is simply based upon the formula of maximum and minimum intensity. Okay. So now let's move away for the next problem, and this question is again same trap. Question is simple, but just because of the fancy dress competition and this makeup, this question is representing, oh, I'm so difficult one. Don't worry. This is just to check the formula you are able to recall or not. Fine. Now consider the situation. Two waves y1 is equal to a1 sin omega t minus this beta 1 and y2 is equal to a2 sin omega t minus beta 2. Superimposed to form a resultant wave whose amplitude is direct result in front of your eyes. A1 square plus A2 square plus twice A1 A2 cos of theta. Fine. Why I mentioned this? At least 3-4 questions directly from the formula recalling. Simple result. If you are able to recall this, good. Otherwise, difficulty. So again do the same approach, colorful pen, write down this important formula, place on the wall, just keep on looking the formula for some time. You are going to be the master of these results. Okay? Not required even to put a pen or pencil. But if you are unable to recall the formula, difficulty. Then once again Young's experiment, ratio of maximum to minimum intensities of fringe system is 4:1. Actually, why I want to use this question again? Reason is simple. I just want to emphasize that this Young's double slit experiment concept and formula and this topic is very important. Fine. The amplitude of coherent sources are in the ratio of how much? Let me allow to write down the simple results over here. I max, although just 2 minutes back I mentioned this result, I min is equal to a plus b whole square upon a minus b whole square. Once you solve it by the same method, b square out a upon b plus 1, b square out a upon b minus 1. Once you solve it, you will get a upon b is equal to 3:1. So it's a repetition, and my suggestion is, moment this question comes at your computer screen, stop the video. Recall that previous explanation. Only then solve this question yourself and then move. Fine. Actually, if you are not attempting from your own, then obviously it's going to be difficult for you to learn. Then it's next question. Now this question is based upon Doppler effect in light. If you are not regularly watching Misostudy videos, obviously things are going to be slightly difficult for you. But if you are regularly watching, try to recall, I devoted one entire lecture onto this aspect of Doppler effect in light. Fine. So here only important is separation or coming closer between source and observer. Accordingly, just one formula and the calculation. So let me allow to mention that formula, that is delta lambda is equal to V lambda upon C. Fine. Solution. And what is that solution? That solution is this nu, delta nu is equal to V by C. Or you can write down delta lambda is equal to V lambda upon C. So similarly, you have to mention nu over here. Now two formulae are in front of you. One in the form of delta lambda, I mean the wavelength, another in the form of this nu. Fine. So delta lambda is equal to V lambda upon C, or delta nu is equal to V nu upon C. Put the values given over here. So 0.2 C. Fine. So 0.2 C upon C is into 4 into 10 to the power 7. Fine. Once you solve it, you will get this delta nu value, and nu prime is equal to nu minus delta nu. Nu is given, so you can easily find out this delta nu, which is 3.2 into 10 to the power 7 Hertz. So this formula in our routine theory lectures is very properly explained. That's why I always keep on requesting to all of you that please keep revising these basic concepts which we already providing you. Fine. Then only you are going to enjoy these questions. Here important, this way important, and obviously putting the values and solving, and then this result. Fine. So as such it is not very difficult, simple one, but because lack of revision, it may possible that you may lose marks. Not only lose marks, but you may get negative marks. So please don't force this situation to come in your result. Now students, I think we should not make this session very longer. Okay, so let's close this discussion over here at proper point of time. Again I'll come back with other these type of questions. Till then, take care of yourself, keep revising, have a very nice time.